Hey everybody, this is Larry. This is January 29th, I guess, or 30th, depending on when you're watching it. I'm doing an extra problem because the daily problem was done. So I'm going to just do an RNG one and let's go. Hopefully not too difficult. And it's a premium problem. It's 1618 maximum font to fit a sentence in a screen. I feel like we've done something similar lately, but I guess maybe, all these problems, I don't know. It is what it is. So you're given a string text. You want to display text on the screen with W and height H. Let me drink some water. You can choose any font size from array fonts, which contains the relevant font sizes in ascending order. All right, that I still don't know what that means, but okay. Return the maximum font size you can use to display text on the screen. Text cannot fit on the display of any font. Okay, so you just try like all of them. Well, I mean, you can also binary search on the fonts. It doesn't really. Right, so yeah, okay. I mean, I guess you should be binary searching if it's in order. And is it in order? I'm trying to look. Yeah, fonts is in sorted, and so we can definitely binary search for it. That's fine. And what are we binary searching for? Okay. Okay, so we get height and get width. I guess height is the same for a font size and width is the thing. So then now we have width and height. Do we like wrap around or whatever? Like for smaller font or for long single line. Okay, fine. I see. That's the question I was asking. That's not that bad then, right? So yeah, I mean, you could do this with a for loop again, but we can just also just do like binary search. I like to do it inclusive. Though maybe for this one, we should choose the okay, yeah. So then now in this case, it should be -1, so that it was smaller than the smallest item. Otherwise, everything will be good, right? Yeah. And then now, if good of mid, then so if this is good, then we can try a bigger one. So we want left is equal to mid, else right is equal to mid -1, and that's pretty much it. This should be, if left is equal to -1, then we return -1. Otherwise, we return fonts of left, right? Now we just have to return good. Good size. Well, this is kind of index, so maybe we can, yeah, okay, fine. So then now font size, yeah. Copy with the thing, and then we get font height is equal to get font info dot get height of font size, and then and then we have to do it for each width, right? Any spaces or anything? No, okay, fine. Okay, so then now if font height is greater than or equal or greater than H, then we return false. Otherwise, we can try the width, and then total width is equal to 0. And then now we have for C in text, we can do font width is equal to font info dot get width font size, right? And then we have total and we can actually cache this function because depending on how expensive it is to call, and we should be able to cache it because it should be the same, right? But we don't, let's not prematurely optimize yet. So if this is less than or equal to W, then we're Gucci. I think that's it, right? Maybe. Missing one requirement. Oh, whoops. Get width. What was it? The character. I mean, I knew that, but I just forgot to type it. All right, so this looks good. there are no like number of cores here, right? Max cores. Okay, yeah, then let's give it a submit. And yeah, and that's pretty much it. A way for binary search. You don't even need to do the binary search. You get done a linear search if you really want to. I don't think it's that much slower. The hard part is just, well, I say the harder part, but the more tricky part is this part, and just really understanding the problem. I don't think there's anything that, I mean, like, if you have to wrap lines or there's spaces or there's like weird things, then maybe it could be trickier. And definitely there are ways to make this problem trickier. But I think for now, for this particular problem, this is fine and this looks pretty okay. And like I said, you could probably cache this because you're making the same core for certain things a couple of times. But I mean, like I said, don't prematurely optimize, and it looks good enough. Looks good enough. So yeah, what's the complexity here, right? Well, this is going to be O of log n. We do log n number of iterations here. Good is going to be well, log. Let's just say n is the number of fonts and t is the length of text. Then this is going to be log n because we go through, you know, log n number of iterations. And here this is going to be O of t. So this is going to be O of t log n. Yeah, so let me write it out for y'all. O of log n iterations. And then this is going to be O of t log n total time. Because good is O of t. Right? And space, well, we don't really use anything, right? We just use O of 1 for some variables and stuff like that. So that's going to be space. And that's all I have for this one. Let me know what you think. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.